When light travels past really big things, it can bend around them. And when it does that, it can make things behind those massive objects appear to be distorted and magnified. This warping and expanding of space is what we call a gravitational lens. These cosmic funhouses have helped astronomers discover thousands of galaxies that would otherwise be too dim for us to spot. But occasionally something weird happens. The way that light is bent by these gravitational lenses doesn't seem to match up with how much mass the galaxies in the foreground actually have. There are two possible explanations for this cosmic mirage. Either the amount of mass in the universe is different than what we think it should be, or there's some hidden stuff making up the missing mass. Dark matter, anyone. The reason that light bends around massive objects isn't just because it's nice and bendy. It's actually an effect of gravity. According to Einstein's theory of general relativity, gravity warps the fabric of space-time itself. So if you want to travel through space, your path isn't a straight line, but rather a curve caused by all the mass around you. The more massive an object, the more it warps space, which means that light traveling near it will get bent more. When a galaxy sits between us and a more distant galaxy, its gravity warps the space between the two, distorting and magnifying the light coming from the background. That creates something called a gravitational lens. When the light rays converge after being warped by the lensing galaxy, the image behind it looks distorted like a funhouse mirror. And depending on how much mass the lensing galaxy has, the background object appears magnified. By studying this magnified light, astronomers can learn lots about both the background object and the lensing galaxy. For example, in 2022, a team used a gravitational lens to study an extremely bright burst of light from a faraway supernova, allowing them to measure things like the age and abundance of metals in the early universe. Gravitational lenses have also been used to find over 50 exoplanets, many of which would be impossible to detect without the magnification provided by the lensing galaxy. But sometimes the light that comes through a gravitational lens doesn't seem to match up with what we expect based on the amount of mass in the lensing galaxy. In these cases, it's like the lens is bending light more than it should. And that's not good because we can use these mismatches to shed light on the missing mass of the universe. You see, while we have a pretty good idea of how much matter and energy is in the universe, everything we can see only makes up a tiny fraction of that. Most of it is invisible, mysterious stuff called dark matter. Dark matter doesn't interact with regular matter, and it's completely invisible to the electromagnetic spectrum, meaning it doesn't absorb, reflect, or emit light. The only way we know it's out there is by watching its gravity affect things that we can see. So it's pretty neat when observations of the universe give us hints about the existence of dark matter. And one of the ways that astronomers infer the amount of mass in a galaxy is by measuring how fast stars in the galaxy's outskirts are moving. You see, the farther a star is from the center of a galaxy, the less the galaxy's gravity is pulling on it. So the outer stars move faster before they escape the galaxy's gravitational pull. If there was no dark matter, then the outermost stars would just drift off into outer space. And if a galaxy has more mass, then its gravity is stronger and it needs more speed to break free. So by measuring how fast a star is moving, we can work out how much the galaxy's gravity is affecting it and therefore how much mass there is in the galaxy. But observations of stars in the outermost regions of galaxies tell us that they have more speed than expected. It's as though there's more mass in the galaxy than we can see, which could mean there is dark matter in the universe. If dark matter exists, it should also be affected by gravity, and it should make up a significant portion of the mass of galaxies. So astronomers can use gravitational lenses to look for evidence of it. They do this by looking at the mismatch between the amount of mass that we expect a galaxy to have based on the speed of its stars and the amount of mass that we need to explain the gravitational lensing effect. In 2020, a group of astronomers looked at a gravitational lens made by a galaxy called J1347. The group used data from the Hubble Space Telescope to determine the amount of mass needed to explain the lensing effect. They also used data from the Karoo Array for Microwave Astronomy in South Africa to map the distribution of matter in the galaxy based on how fast gas was moving in different parts of the galaxy. They compared the amount of mass they inferred from the lensing effect to the amount they calculated from the gas in the galaxy, and they found a mismatch. The lensing effect suggested there was about 3 times more mass than the gas in the galaxy indicated. Now, there are other possible explanations for this discrepancy, such as if the gas isn't spread out in exactly the same way as the dark matter, then we wouldn't see as much of an effect. So more data is needed to confirm that there's actually an extra 3 times the mass. But even if that's true, this one galaxy isn't enough to draw conclusions about the entire universe. We need to look at lots more. A larger study published in 2023 used data from the Hubble Space Telescope to analyze 16 gravitationally lensed galaxies, and they found that in 7 of them, there seemed to be significantly more mass than we would expect based on how fast the stars were moving. And when they looked at the distribution of that extra mass, it seemed to be in the same places that we would expect dark matter to be. What's more, in one of those galaxies, the authors were able to estimate the amount of dark matter in the galaxy. They found that about 90% of the mass in the galaxy is dark matter. While that is a single data point, it agrees with other measurements of the amount of dark matter in the universe. Of course, while this is exciting, we won't know for sure that dark matter exists until we directly detect it. But with studies like this, we can continue to narrow down what dark matter might be, and hopefully one day we'll answer the question of what makes up most of the universe. While we wait for that, we can enjoy beautiful images of the universe captured by the James Webb Space Telescope. Thanks for watching this SCI Show video, and thanks especially to our supporters for making it possible for all of us to explore the universe.